Solving for the intersection, which is what part B is asking for, is the same as linking the equations by end. Since we still have the same inequalities, we still look at the same lines with the same shading, but our final solution is only looking at where the shadings overlap. Meaning everything that's shaded in blue is our solution for the intersection. And it's where the red shading and the green shading overlap. And just to make it very clear, that is the solution to part B. Okay. Next, we want to graph the following inequality of the absolute value of 2x plus 5 is less than 3. So let's come over here. We'll erase what we have. Assuming my computer wants to work with me. There we go. Alright, so recall we're looking at the absolute value of 2x plus 5 less than 3. Since this is an absolute value, we want to split it into two equations. 2x plus 5 is less than 3, and negative 2x minus 5 less than 3. In both, since x is our only variable, I'm going to solve for x. I get x is negative 1 for the first version, and x is greater than negative 4 for the other one. I'm going to put both graphs in a Cartesian plane. Again, make sure that you number and label your axes. For x is less than negative 1, since this is strictly less than, we get a dotted line at x equals 1, and because it's less than, we know we're going to be shading everything to the left. Now for x is greater than negative 4, we get a dotted line at negative 4, and because it's greater than, we're going to shade everything to the right, which means for this absolute value, we're shading the space in between our two parallel lines. And that is my solution set. Okay, next we want to find the standard form for a circle that has n points of a diameter of 1, 2, and negative 5, 8. For this one, recall the general equation for a circle. And that is x minus h squared plus y minus k squared equals r squared, where the center is h comma k and the radius is r. We are given that the circle's diameter has n points at 1, 2 and negative 5, 8.